of a photoelectron if the work function they have given, which is 1.24 electron volt, and the wavelength of the incident light is 4.36 into 10 power minus 7 meter. So you carefully listen to this question, because there is a unit conversion, an important unit conversion problem will come here, because you can't always solve all the problems in electron volt. So that is what we are going to do here. So here the question I'll just pictorially represent. There is a metal plate. Its work function equal to 1.24 electron volt, and there is a radiation of wavelength 4.36 into 10 power minus 7 meter, or this can be 436 into 10 power minus 9 meter, or 436 nanometer. Because all the wavelength, if you write it in nanometer, it is very easy for us to apply the formula which we already know. See here, what is the velocity of the photoelectron? So this is the incident energy. This is incident wavelength. Using that, we are going to calculate the incident energy. Incident energy is equal to 1242 electron volt nanometer by lambda. Lambda is must be substituted in nanometer. So 436 nanometer. When you substitute, nanometer will be cancelled. So energy of the incident radiation is 1242 divided by 436, which is roughly 2.85 electron volt. So in other words, you can say that incident energy is 2.85 electron volt and work function is 1.24 electron volt. So remaining kinetic energy of the electron is equal to incident energy minus this. So the kinetic energy of the photoelectron is 2.85 electron volt minus the work function 1.24 electron volt. So when you subtract this, you are getting 5 minus 4 1, 8 minus 2 6, and 2 minus 1 1, 1.61 electron volt. But what they are asking is, they are supposed to find the velocity of the photoelectron. So kinetic energy equal to half mv square. Because we are talking about the kinetic energy of the electron, this is mass of the electron, this is velocity of the electron. So the kinetic energy they are finding out to be 1.61 electron volt. We can't directly substitute this here. Mass is in kilogram, velocity is in meter per second. So energy must be converted into joule. Hence the formula is half mass of the electron 9.1 into 10 power minus 31 kilogram, velocity square is equal to 1.61 electron volt. We know that 1 electron volt is 1.6 into 10 power minus 19 joule. So 1.61 electron volt is 1.61 into 1 electron volt. So this 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Now this is in kilogram and this is in meter per second, this is in joules. So all are in SI system, no problem. So here the next step is keep V square as it is, and here 1.61 into 1.6 into 10 power minus 31 minus 19. So minus 19 minus 31 going on to the other side plus 31. This 2 is coming to this side divided by 9.1, because this minus 31 I have brought it here already, because otherwise minus 31 will come here and then it will go up. So since it is a square, there are two 1.6 and roughly 9 is there. So when you take square root, so actually roughly the value is roughly 1.61 into 1.6 into 10 power 12 and 2 the square divided by 9.1 into 2. So this is V square. If you want V, you have to take square root. So 2 1.6 roughly, so it becomes 1.6 and 2 becomes root 2. 10 power 12 becomes 10 power 6 whole divided by 9.1. 3 3s are 9. Roughly it is equal to 3. So this is not the exact answer, maybe here or there. So since I'm just doing it as an example, I'm just approximating this. So 1.6 by 3. So 1.6 by 3. So what value is there for 1.6 by 3? 1.6 divided by 3. I'm getting it here. 0.53 into root 2 is 1.414 into 10 power 6 meter per second. So 0.53 into 1.414, I am getting 0.75, 0.754 into 10 power 6 meter per second, or the velocity of the photoelectron is 7.54 into 10 power, one digit move here, subtract 1 meter per second. So in the book also I have got the same answer. So in this case approximation also works because it is 0.01 whole power minus 19. Hence this approximation works here.